Okay, welcome to the space, everyone. Thank you for tuning in. We have a really great discussion planned for tonight. On stage, we are joined by Patrick, the co-founder and CEO of Onicai, as well as ICPP Pro, the co-founder and CTO of Onicai. Onicai is the premier decentralized AI solutions developer house on ICP. And tonight we're going to be discussing their projects as well as the future of AI on ICP. Welcome, gentlemen, to the space. How's everything going?
Hey everyone, thank you Zen for having us. All good here. How are you?
Doing great. Yeah, really quick. So we have like a 2-hour cutoff for this space, so we're going to try to keep things moving. Before we jump into the discussion, just a few quick housekeeping notes. First off, please make sure to like and retweet the space. This is going to be a fireside chat discussion, but we will have time for audience Q&A afterwards. And lastly, I just want to remind everyone that this space is being recorded tonight and will be available for anybody who missed it. So with that, we're going to jump right into the discussion. And first off, I would love just to get a little bit of information about both of your backgrounds. What is your experience? How did you find ICP? How did Onicai get started? And give us a little bit of insight into what your role is at Onicai.
Yeah, sounds good. Thank you. I'll kick it off, say a few words about myself, then hand it over to Arjan. So my background is in software development. Did my university degrees there as well and had the opportunity to work on AI as well as blockchain technology there during the courses and projects. And so, yeah, Onicai is really bringing it full circle by being able to combine these two technologies, and worked as a software developer with a startup in the US for a while, and then decided to hop full time on ICP. And I really, when I started looking at what's possible on ICP, I really felt like all the promises that were in the space, in the Web3 space, could finally come true around decentralizing different applications and really having full stack decentralized apps. And I found that super exciting, this new approach, and definitely wanted to be part of it. Worked on a couple of projects. Started learning about it, for example, also with the Motoko Bootcamp back then. That was great. And more put the focus on AI on ICP. And also that's how Arjan and I got in contact first. And I'll hand it over to Arjan at this point.
All right. Awesome. Yeah, thank you. So yeah, my name is Arjan, or ICP. I listen to that too. I'm originally from the Netherlands. I'm actually an aerospace engineer, but I always worked in software development, kind of similar to Patrick. My focus was always on high performance computing. So I always worked in the field of doing these really compute intense type of computations on powerful hardware. I moved to the US in the 90s, so I'm living in the Detroit area now. And I discovered the IC when I was interested in blockchain in general. So I was working at that time for a company that has a conversational AI platform. So I was working in the field of AI, and I was just looking around for interesting aspect of blockchain. Of course, you look at Bitcoin, look at Ethereum, learn some Solidity, and then about 6 months after genesis of the internet computer, I discovered that, and I really liked it. It really spoke to me with the what you can do on it, and I've been working on it on some grant programs, and yeah, some of the things that we're doing today that we'll talk about really come from that background with my computational background.
And then how Arjan and I got started working together was really by seeing each other's work. So I saw the work that Arjan, back then, to me, he was just ICPP Pro, did with the CDK, but then with really running the first large language models on chain. So that was super exciting. I was working on a different approach to DAI, that is running the large language models on your device, that is your laptop or smartphone, and serving these models directly to you via a web application that's hosted on ICP, and the backend, for example, when you want to store your chat history, is also stored on ICP. And we saw each other's work, started talking, and decided, yeah, that makes a lot of sense to combine our work and working towards this really uh, hybrid decentralized AI space, because there are different solutions, and luckily we also see different approaches within the ICP ecosystem and also the broader Web3 ecosystem to decentralized AI. The first thing that came out of it was really because we started talking regularly. We said, this is great, a lot of knowledge exchange going on. Let's open this up, and why not try to establish a decentralized AI working group for ICP? And yeah, because of the great response from the community, we've really been having more or less weekly calls ever since November 23. And so that's been great. Also, at this point, like if any one of you wants to join the AI calls, they are on Thursdays, and it's very much an open platform. Everybody's welcome. So that's the first thing that Arjan and I, in that sense, started. And then the other thing was really Onicai, because as I mentioned, we said, like, would be great to combine these approaches, work together, and together push towards the common vision of self-sovereign AI and pushing decentralized AI on ICP forward.
That's great to hear, and it's funny. Just a side note. I mean, it's great that we're talking now, but I'll say to Aryan, I've been reading your stuff on the forums forever, man. If anyone is on Dfinity forums, you've probably read some of Aryan's posts before. So
I appreciate that. Yeah, the forum was really, yeah, I was on the forum before I came to Twitter or X, for sure. Yeah, that's where you learn it, right? That's where you learn, and where you ask questions and can go back and forth. So yeah, thank you.
let's dive a little bit into Onicai. I mean, you guys have a lot of stuff going on, but just to start, give us just a brief overview of really what Onicai is, what your vision is for it, and how long you guys have, when did it start, and how long have you been building on the IC for?
So Onicai really started pretty much exactly a year ago. Arjan and I both have been involved in the ICP ecosystem since the mainnet launch, and I'm working on projects mostly on AI. Um, and then last year really started officially with Onicai. Our focus back then and also today was self-sovereign AI, so really making it possible for individuals, but also companies and other entities to run and control their own AI models in this decentralized approach, because that way we think AI can be decentralized and also democratized, and it can bring a lot of benefits to the broader space of AI as well, where we see this merging of decentralized technology with AI in terms of controlling it, coordinating it. And so we've been working towards the vision of self-sovereign AI that is also on an individual level, as I mentioned, really for you to control your own AI agents. But then the question obviously arises, once people use these agents and you and I have our agents running out there, can we also contribute to providing tooling for coordinating them? And so we've been working on a lot of tooling to support all of that. So for example, make it very easy to spin up canisters that run AI models, or spin up AI solutions on the IC, and thus leveraging what is in place to make it easy for everybody to use the technology that there is. And these will be individuals, but also other projects. So our focus is also to bring this technology to other projects in the ICP space and make it easy to iterate, build on top of it, and thus benefit broadly from AI.
Yeah, maybe I can add to that a little bit also. How we both started out. I mean, we really didn't start building right away with the concept of Onicai, which stands for On Internet Computer AI. Right? We didn't start both of us like that. So I started just building because I thought it's an incredible environment where you can build things and you can deploy it so easily and share it. I mean, it's truly amazing how the internet computer enables that for developers like myself, where I'm not a web developer. I know more the backend type of code, but I can still just develop it very easily, as I always have done, and then deploy it. And you have to learn the interface, but it's there. It's out there. It's really amazing. And then when so I started working on the C++ side. At that time, I had like AI in mind, but not really. It was just like, I want to do computations on it. And then the LLMs came into the world. So when that happened, I think that was really the moment where the things fell into place, because the LLMs is one of these high performance compute applications that we realized if you can get that to run in a decentralized manner, either in a canister, what I was focusing on, or in your browser. There's a lot of stuff going on with running high compute applications in the browser using GPUs or web LLM is available. That was really the moment where we realized, this really is something that is possible to run fully decentralized AIs, where even the LLM itself runs decentralized. And that's when we realized that it's really a thing. It's really possible. We doubled down on it and created Onicai.
And the really that enables the self-sovereign AI, kind of for us a defining factor of decentralized AI, but then also a network of decentralized AI agents. Because if all of us are running their own AI agents, they will be able to interact. And so our focus from the get-go was really, okay, how can we contribute to this decentralized AI network, where instead of the intelligence sitting in like one single place behind an API controlled by one company, maybe there will be 2-3 companies that all control these huge models, right, with like OpenAI, Google. But what is the alternative? And the alternative we see is that the intelligence is really in the network with like many different nodes. And so the overall the network provides the intelligence, and instead of us all consuming one central intelligence from one player.
Yeah, and I'd love. I can't wait to get to the audience portion of this. So, guys from I know, we have Bobby in here, Spider Whom, and a lot of guys working to cover AI and talk about AI. And I'd love to dig into those principles more. But before we do that, I mean, you have a couple of products as well as sort of technology milestones that you've hit recently. Let's cover those briefly. So let's start with DaVinci. Tell us a little bit about DaVinci, what it is, what your vision for that product is, um, and yeah, let's go over that first.
Yeah, sure thing. So that's really the first AI application I got started with. Originally, I worked on a metaverse project and wanted to integrate AI capabilities into it. So really having an AI agent within a 3D virtual space. And back then I looked at the different ways to do it and found this web LLM approach. I also remember the forum was helpful, like sorting through different options back then, and found this. It's a library called Web LLM. They really do fantastic work in enabling large language models in a browser environment. And yeah, I just was fascinated and started building with that. And then that turned into an AI chat app with the idea that this AI chat app enables running the large language models directly in the browser. So the user, as a user, you first download the files needed to execute the large language models to your laptop or smartphone. Then you can go offline because everything is downloaded, right? And then it just runs on your local device. And it also DaVinci also works anonymously, so you don't have to log in. But if you log in, you have the option, for example, to set certain settings, including if your messages should be stored, and if so, that would then be on ICP. So the app is being served from ICP, and the backend lives on ICP, but the AI models themselves, they actually run in the browser. And I was very surprised back then how capable these models are and what's actually possible in terms of running large language models on your personal device. I don't have a state-of-the-art laptop, but still, like, pretty good models can run on mine. If you have a powerful Mac, you can actually run some of the biggest open source large language models. So, for example, Llama 3.2 with 70 billion parameters. So really a fantastic model. And the original idea there was just there was Web LLM as like this great library to put the general technology in place, and creating an AI chat application with that to make it easily accessible. So you literally go to the web tab in your browser, and you can start using it. So you don't have to be a developer to install all of it. And at the same time, fully decentralizing it. So really like an end-to-end decentralization by having the backend on ICP and the overall application served from ICP as a decentralized cloud, basically. And then we started working with Nuno, who's a great UX designer and UI developer, to really make that interface look professional, because my skills are too limited on the UI side. But he really leveled up the interface, and super happy with the result. I think it looks like a professional app now, and the really with a great user experience. And so yeah, that's the first AI chat app that I worked on, and as part of Onicai, we really pushed forward.
Drowny, feel free to jump in with any follow-up questions on this stuff. Do you have anything on DaVinci?
So you basically download the model to your browser, and the model's running locally, right?
That's right. Yeah. So it's downloaded to your device directly through the browser, and lives in your browser cache. So the the browser environment is actually very powerful, and some of the browsers have implemented the necessary APIs very quickly, notably Chromium. So what's done under the hood is that the Web GPU API is being used, which every browser should expose. Not all of them do it yet, but at least important ones do. And then the large language model, basically from your browser cache, can use this Web GPU API to accelerate the computation. So the speed becomes pretty good. it then obviously depends on the hardware that you have. So depending on how much memory your laptop or smartphone has, and if you have GPU support on it, it would all be faster or slower. And one thing that we do on DaVinci to support different kind of environments and different devices is provide a broad spectrum of different models. So there are very small ones all the way to, I think, 100 million parameters. So they run even like very smoothly on smartphones, all the way up to the big being Llama 3.2 with 70 billion parameters, which only runs on like a pretty powerful Mac. But still, like you can actually run it on a Mac, which is quite amazing. And we provide all kinds of models in between. So there are models with 500 million parameters, 1 billion, 8 billion, and all of these are really state-of-the-art models that are have been open sourced by different players in the AI space. So there are the Llama models from Meta, Quen. There are more independent ones. Let's say the newest edition we had were the DeepSeek ones. So it's amazing what's going on in the open source community in AI. And again, like many kudos to WebLLM as the project that's pushing this basic foundational tech layer to be able to run large language models in the browser environment.
Thank you. And I like that you have a setting to allow the AI creativity level, and you can basically adjust the responses from short to long. I think that's very ingenious, actually. So I've been playing around with it ever since I downloaded DeepSeek on it. It's been doing pretty good.
Cool. Yeah. Thanks for the feedback. Yeah. So that, in some sense, really also goes back to the control we want to provide users, whether that's on DaVinci or other products and projects we work on, to give the user the control over their AI experience, right? And these settings where you can control creativity, or how long the response length should be in general, or the general um, template for the system prompt, so kind of the role the LLM is to play in general. All of these are things that we think the user should also be in control, and hopefully we can make that easy to accomplish.
Let's talk a little bit about the DeepSeek in a canister milestone. Can you tell us more about that? You've been putting models into canisters, and yeah, tell us about DeepSeek a little bit.
Yeah. Let's. So I want to first mention, um, going repeating what Patrick said, that we built on top of open source, right? And everything we build, we make open source because we feel it very important, and it really helped us out both with the in-browser approach using WebLLM, where no, the latest models are just coming available and we just plug them in, works great, and we just build apps on top of that. And the same with the LLM in a canister. So once the C++ CDK was matured enough that I could port like pretty complex C++ libraries to run in a canister, one of those libraries that I focused on was an LLM inference framework. It's called llama.cpp, and it's really famous. It's one of the most used and leading inference frameworks. A lot of times when you are interacting with a hosted LLM somewhere, it might well be that llama CPP is just being run in a Web2 server, for example. So I actually got a Divinity grant to make the port of llama CPP into llama CPP canister, and that was completed. And the LLM that I used at that time, that was the first LLM, was Quen 2.5. That was one of the most promising open source LLM available when I I released Llama CPP Canister, and the model that I loaded in was a 0.5 billion parameter model, which it performed really well. I mean, that LLM is already very good. So once Llama CPP is running in a canister, it's just like with web LLM running in the browser. You literally can upload any LLM that's available for you in a certain format. So when DeepSeek came out, and it was just amazing what happened with the DeepSeek and the news stories and how it performed and everything. Um, we really were waiting for, okay, when is it coming available in the format that Llama CPP can handle? And literally within a couple of days, it was out there. So if you go to Hugging Face, that's a website where the AI research community, they upload all their models and all the data and all the research. You can find everything. So the DeepSeek uh, model came available in the format that we need in the canister environment. And the one thing I had to do is Llama CPP was updated to support DeepSeek. So I had to update Llama CPP Canister to the latest version of Llama CPP. And once that was done, I could just try it out. So I picked one of these models. They're available in different sizes. And last week, I think it was last week, Friday, I got it running and I just uploaded a DeepSeek model that had 1.5 billion parameters, which is 3 times bigger than in parameter wise than the model I ran before. And fingers crossed, and I started trying it out, and it worked. So yeah, that was really I think another real confirmation for us that using open source is the right thing to do, because these type of really big steps forward in the technology, we can then build on, integrate, and contribute back to the open source community. So that was really the background. The and then I posted something on X about, hey, we got this thing running in the canister, and that just blew up. There was so much interest in that aspect, that you can run a 1.5 billion parameter LLM in a canister. It's like, wow, that's amazing. And I looked back and I said, well, what the first LLM we put out there was a 15 million parameter. So in 17 months, we were able to scale it 100 times. And I think that also speaks for the the power of the Dfinity team with all the changes they have done to the internet computer and the canister environment, and the way you work with storage, the way you do your computes, all of that contributed to being able to just run this model in a canister today.
I definitely have questions about, I'm really focused on, I'm not an engineer, I'm focused on big picture things, big picture sort of principles. Maybe we could just briefly touch on why it would make sense to run an LLM in a canister. Could you just big picture, sort of using layman's terms, touch on why that would be important, maybe what that would enable? Just touch briefly on some of those points.
Mm-hmm. At the heart of it, it goes to the sovereign AI. That if you can run the LLM directly in a canister, you have full control over it. So at the big picture, that's bottom line. It. The more control you have, the better it is. If the alternative is that you use an LLM that's hosted somewhere else, and then when you have conversations with that LLM, you're literally having conversations with somebody else that can see everything that you're doing. You don't know where it's going. So the aspect of control over your data, um, knowing what's being run. So as an individual talking to an LLM, that's where your conversations that you have control over. But you also should think about it in the bigger picture as a organization or a company, right? If you are putting out an agent or you're putting out an LLM as an organization, and you're relying on a managed, centralized LLM, all your conversations that your end users have with your LLM end up with the third-party service. So you're basically giving everything away. You're giving all your IP away. You have no control over it. If I'm not even talking about potential price manipulation that can happen, you're at the mercy of that third party. I'm really talking about the intellectual property that you're basically handing off.
And interestingly, Trevor brought this to my attention. There were some news just broke that DeepSeek was it wasn't hacked, I think, but somebody found a vulnerability, right? I don't know if it's crossed your radar, but it was breached, right? They breached. They figured out a way into a database, and they were essentially able to access all of the chats, right? Yeah,
Yeah.
so that was a huge leak, and people are putting their private keys and trying to create trading bots using DeepSeek, and yeah, if there's a breach on that level, it's like you're risking your money, right? Anything attached to a private keys or sensitive data. So,
Yeah, exactly. And and again, at the big picture level, if you can do all of this in environments that you control securely, all of that goes away. So, and that's why we are focused so hard on trying to make this possible.
Yeah, so there's really this control aspect. So the same way, I guess all of us own cryptocurrencies, potentially some NFTs. You can expand this concept to many things, and then controlling your AI agent kind of becomes like owning your NFT or owning your cryptocurrency. It's tied to your digital wallet, to your digital identity, and you really have everything in under your control, and it's up to you. Obviously, you can get help with some providers or developers to help you maintain the model, but at the end of the day, you're in full control. The other thing I think is worth mentioning is accessibility. So the ICP's canister model makes it super easy to spin up canisters as computation and storage units. And that is something I would argue is not possible on other platforms, including Web 2, where to run an application like that, you usually need a DevOps team, and you need knowledge of the cloud providers like Amazon Web Services. What kind of security groups do I need to configure? What kind of services do I need to spin up there? How do I install all of that? Yes, if you are a developer and you want to put in the time, that's possible, but maybe you don't want to put in the time, or, which is much more common, you might not have the technical skills to do it. So with on the IC, we can literally abstract all of that away, and we have built prototypes that we will are looking to put into production hopefully soon, where you can click one button and it spins up all the environment you need to run your own AI agent completely on ICP. And so that's really something I don't think we've seen anywhere else. This kind of level of accessibility, and at the same time, we are not doing it on for somebody else, but we by using the service, you stay in full control because the canisters get tied to your digital wallet, and that's definitely something that's not possible on Web 2 easily, or actually at all, most likely.
Yeah, I really like that vision. Oh, sorry, were you about to say something, ICPP?
Yeah, I was gonna add one more thing really when Patrick was talking about. I mean, we do have a system in production, right? If you look at the Charles AI NFT, that has a battery of LLMs running in canisters to generate those funny stories. And I think that's actually a great example where this is something that was very, I will almost call it simple. It's actually, once you know the internet computer, it's actually quite simple to set something like that up. You just need to learn how to deploy the LLM canisters. You need to learn how to call it. You need to learn how to build some front end for it. In this case, it's these are AI NFTs at Bionic, and then you just deploy it and you're done. If you would set this up in at AWS, we would have to spend probably a lot of time every day to maintain it. You have to look at your security. You have to look at your your keys in order to make secure calls. All of that's taken care of for you by the internet computer. So after we deployed it, it's really just deploy and let it go. And we we uh, we need to make sure the cycles are topped off. It's really amazing that we put it in production in December, and it just has been up and running automatically. So, and in a Web 2, what I wanted to point out with this is people are sometimes very, very focused on, can I run the biggest model possible in a canister? What is the cost per call? But I think people need to look at it totally different, because something like the Charles AI NFT project, the total cost of ownership of doing that project in a Web 2 environment would be way higher than doing it on the internet computer. So people need to start looking more at the total cost of ownership and the real use cases of LLMs within their projects.
Mm. And I think it also highlights another important point. So uh, this is an AI NFT. It's really not in that sense possible without running the AI on chain, because everything has to be really on chain for this NFT to make sense. And so if you have your tech stack on ICP, or you want to have it fully on ICP, then and integrate AI features, then often running the AI on chain in a canister as well could well be the simplest approach. And depending on what kind of functionality you need, it might be fully sufficient in terms of the model sizes that you can run. And then it becomes very easy to integrate and very easy to maintain. Plus, you don't end up with like a hybrid architecture with like some components running off chain, but it stays fully on chain, fully on ICP.
I love what you said there, total cost of ownership. I think, yeah, I mean, we look at these technologies in a vacuum. How much does it cost per call, right? And we're not taking into account the total cost of ownership. And yeah, I think that's going to become increasingly more relevant. But I'm really glad you touched on that. I want to we'll let Drowny have a question, and then I want to move on to proof of AI work, because I really want to open this up to the audience as soon as possible. So Drowny, you go ahead, and then we're going to touch on proof of AI work.
Okay, so yesterday we had Patrick hosted the decentralized AI working group, and we talked a lot of the technical details. But I just wanted you guys to kind of go over a high level overview over the cost of the DeepSeek LLM in a canister. How much does it cost, and what are the future um, solutions we could do to lower that cost down? I know there were a lot of solutions proposed by Definity, and so many great engineers in that call. But just at a high level, like explain the current state of the cost of DeepSeek in a canister, and what are the future solutions going forward.
Yeah, I can talk that. It was indeed a great call yesterday, where we had a lot of new participants in the call, and also Islam from the AI lead at Definity was in the call. Jessley from the Side AI was also in the call, so we had a lot of good discussion there. Um, so DeepSeek is running in a canister. Um, the When you make a call to DeepSeek to to start working through a prompt, right? That's how an LLM works. You have a question and a prompt, and you have to send that, and the LLM first has to basically chew through that prompt to understand what it's all about, and then the LLM starts generating tokens. So both working through the prompt and generating tokens, that takes computations. The DeepSeek model with its 1.5 billion parameters, it's really quite a large model. And the number of instructions to work through the prompt and to start generating tokens, um, it is possible. The canister has an instruction limit. So when you make a call to the canister, it has an instruction limit. And after 2 tokens, the canister will hit the instruction limit. So when you want to integrate the DeepSeek LLM in an application, your application has to basically call the canister multiple times. And every time you can ask it to generate 2 tokens, and you have to just go through that. So from there's no limitation on having a conversation with the LLM. There's no limitation on the context that you can provide it. You just have to call it multiple times. So that, of course, limits the practicality of using this LLM. We still think that it's possible by using some techniques that we're looking at to use it in applications. Latency and costs are going to be quite high, and that's where a lot of the focus is on making that better. And that's where Islam from Dfinity yesterday, he really brought up a lot of you know, interesting concepts that Dfinity is looking at. There will be there's ideas for dedicated environments that actually run the LLM, which without such an instruction limit. So then that's all gone. It will go. You call it, and you just can get it as much as you want. That would be one huge possibility. There is discussion about upgrading the nodes themselves, so then you can get again more faster throughput. So that's where a lot of the improvements will come from. The LLM is now running; it's there, and it's just a matter of increasing either this instruction limit, improving the nodes, having a dedicated maybe GPU environment to run it. But nothing holds us back to already build applications with it.
Quickly, yeah, just bang out one of the questions I had in my notes. Could you just give us a brief idea? So, Dfinity, this DAI working group, is thinking about a lot of different approaches to these challenges. But concretely, what are some of the network upgrades you guys are looking forward to, and specifically network upgrades that will boost AI capabilities on the IC?
Mm-hmm. Yeah, the 2 I mentioned. If there's a way that the instruction limit can be increased, so we can get faster throughput, that would be huge. A dedicated environment to run the LLMs, that would be the second one. I don't know, Patrick, if you have any other additions to that.
Yeah, I think these are great, and personally also looking forward to the vet keys feature. So basically this decentralized approach to encryption keys. And so for example, we've been trying that out in an early DaVinci prototype, because it would really mean if you decide to store your chats on chain, then they would be fully encrypted. And so you would, in some sense, have a complete gold standard of private AI. That's what we have in mind there. And so, yeah, that would be really interesting.
Great. Let's move to proof of AI work. This is the thing that made a lot of noise yesterday. I know a lot of people are excited to hear about this and hear about the future of this thing. I'm just going to let you guys talk. Just tell us, give us a general overview of what it is, kind of where you see it going. And I know Drowny has definitely a number of questions on this, so I'm going to let him go back and forth.
Yeah, sounds good. So the proof of AI work is really something we've been thinking about for a moment. First, more from the perspective, okay, how can, from the perspective of self-sovereign AI, so if I'm running my AI agents, how can I know for sure that they are doing the work they are supposed to do? How can I know they're acting in my best interest? So we need some kind of track record and to facilitate really the control also during runtime. And at the same time, you can expand this to, let's call it a multiplayer approach, where if you and I have our agents running and they're supposed to interact out there in the world, how could we coordinate these interactions? And basically that can then be done within a protocol. So with the proof of AI protocol, we are addressing that. So really this also coordination mechanism, and it's a concept we wanted to share, in some sense also an open call for innovation. Very happy to see the engagement and everybody who's got an idea and wants to develop the concept further, is thinking about a specific way to implement it. For us, it's really a way to say, okay, if there are multiple agents in the system, how can we build a system such that we know the AI is doing the work it's supposed to do, and the overall outcome is really what we're looking for. So if we look at a simple example, you could run several agents that are competing, and for each challenge that the protocol generates, they are supposed to generate a response. That response again is judged by the protocol system, and then the best fitting response basically wins that round for the challenge, and can, if you want to, include a token, mint a token, or get a reward in any other way. So it's in some sense the same thing we've seen with proof of work or proof of stake consensus algorithm, where there are multiple parties involved and you want to coordinate them to together work towards a bigger goal. We think this can be done with this idea, and specifically focused on coordinating AI agents.
Awesome. So I'll start off with my first question about this. When I read your light paper, I just a lot of things came into my mind. So first question, is this something that you view as it's going to be like a standalone network, or do you view this more like a framework where anybody can spin up their own proof of AI work?
Yeah, we've been thinking about it really as a framework. There can be, we hope there will be different implementations of it, and maybe we can make them all compatible if it makes sense. But that's really up to the developers to make these design decisions. So we think there are certain building blocks that make the proof of AI work what it is. So for example, verifiable AI, but for example, that doesn't mean it has to run on-chain. We think that that it's a straightforward approach and a good approach to do it. And we're also working on a implementation of proof of AI work with fully on-chain. But there can be different approaches, and I think we've seen some great ones also in the ecosystem. For example, around zero knowledge proofs from NovaNet, or what the IC Panda team put out in terms of running the model in a trusted execution environment and then having state on chain. So there can be different approaches, as long as the developers think that these are still verifiable AI running there. And then different components can be used to coordinate them. So like a reward mechanism, a way to generate these challenges. So for example, in the system we're building, that also will be done via on-chain AI. So an on-chain AI model generates the challenges, but maybe for other use cases, it makes more sense that humans are in the loop, or maybe of these challenges are fully human generated. And for example, if you're thinking about a broad network which acts kind of like a job board for AI agents. So everybody can post certain tasks they want to have fulfilled there, and AI agents pick up the tasks, and then several AI agents pick up the same task, compete to get each generates a response to it, and compete then who is generating the best one, and there is then an evaluation mechanism to decide, okay, with the rules that were put in place, this is the winning entry and it gets a reward, maybe for this kind of like open job board for AI agents that can be literally the bounty price, but maybe there's also a newly minted token tied to that, or there's just a payout in ICP or what have you. So yes, we think of it firstly as a framework and hope to see different kind of implementations with different kind of design decisions. Um, we also hope there will be like huge networks that take some of these ideas that we put out with proof of AI work to make these networks in that sense trustless but still verifiable, and give the users a really a guarantee that the work that the agents are supposed to do is actually being done. Um, yeah.
Yeah, maybe I can also add a little bit to that. Um, so what was put out is indeed, it's called a super light paper. So it's really more at the conceptual level, what we feel proof of AI work means, what it can do. We're actually, as Patrick said, we're actually implementing a fully on-chain example of that. And as we're building it, we're probably learning more if what it really means, right? The proof of AI work. It's a very kind of new concept, new idea. And I believe that as we are building an implementation of proof of AI work, maybe hopefully others will also build systems along that concept and share their information. We believe that that concept will evolve in a more specific set of rules, maybe even specification of what it means to have a proof of AI work application.
Yeah, and if we zoom out a little bit, it's really also for us a contribution to what we think is important. And again, that's self-sovereign AI, and that's also basically how can decentralized technology make an impact for AI and basically help us design a better system overall. And if we think about probably very soon, millions, billions, I don't know how many AI agents running out there, um, we most likely will want some kind of control and guarantees that they are doing what they're supposed to do. And we will most likely also want some kind of coordination mechanism to guide their interactions with each other and also with us as users. And we hope that can just start a discussion, and we'll see a lot of innovation happening in that direction, because we think it's very important to think about that, looking at the future we'll have with AI agents, which on the one hand is very exciting, but it's also important to get it right, I guess.
Yeah. And maybe one last item in the in that super light paper was not called out how to build it, where to build it, right? But we are building it on the internet computer, and we are realizing right away that the internet computer is a great environment to build it, because just the way it works. Because when you build an implementation of the proof of AI work, it means you need to do work, and it needs to be self-sustainable. And the mechanisms that the internet computer offers with this reverse gas model, with the cycles, the fact that you can send cycles with messages. So if you're doing work, you're actually sending cycles. You're paying for submissions. There's all the items to make a kind of a self-funded, self-sustainable, fully autonomous proof of AI work implementation. They're all there on the internet computer, and to build something like that somewhere else would be a lot harder to do. So we it was not spelled out in the paper. It's not part of the overall concept, but when you look at actual implementations or something like this, we feel the internet computer is a perfect platform.
Especially also given all the capabilities in place, important for us, for example, with on-chain AI, but also all the chain fusion capabilities. And I think what we are seeing and will see more and more is a form of chain fusion AI agent, which really leverages all the capabilities the IC has in place. And there are many on-chain capabilities, and then these agents can leverage the chain fusion features to go out and interact with other systems as well. And if we find a good way to basically anchor the control and the coordination via ICP mechanisms, that would be awesome. But yeah, if other teams out there work with different approaches on different platforms, and maybe the concept we put out gave them some interesting ideas to look into and integrate, that would be awesome too.
Great. So I believe you all have answered my second question, which is the type of challenges, and I believe it's open-ended. So every implementation, it seems like the challenges could be tailored towards a specific domain knowledge.
That's absolutely right. Yeah. So for example, you could think about a specific implementation of proof of AI work where it's about finding the best trading bot, and then that can be designed such that over a bunch of rounds, each challenge would be a basically a trading environment. How does the bot behave in this um, given the data? How well does it do? And all the miners in that sense, all the AI agents would then compete to show their performance, and the outcome could then be the basically which are the best trading agents under which conditions. But it can also really be, as I mentioned earlier, for example, with a very general job board, something like you have on Fiverr, right? If you're familiar with that platform, where everybody can basically offer their services, and I guess there are also features to request services, and we most likely will see something like that also with AI agents. So that's also a path forward. But these challenges can also be something more specialized in terms of maybe content generation or image generation, or for entertainment purposes. There are really no limits to that, and it depends on the implementation, as you said. Yeah.
Awesome. I want to be mindful of time. We do want to segue into the ICPP Pro Bootcamp. So I'll ask this last question. For this, you mentioned that you're going to build the first implementation of proof of AI work on chain. For people in the audience, would what programming language would you recommend to start off with to kind of like get started with building AI models? Would you recommend C++, or is it more programming agnostic where it could support Rust, Python, Motoko? Like what are like things that people should start out with in terms of actually building AI models on proof of AI work?
The I would say if you already know a language, just use that, because you can. That's a nice thing about the IC, right? You can write in Python, TypeScript, JavaScript, Motoko, Rust, C++, whatever. Um, To deploy, let's say, the Llama CPP canister, you actually don't need to know C++ at all. If you just work through the README instructions, you just need to know how to type commands into your command line terminal. That's it. You really do need to know the C++. You need to know how to call a canister. So to use on-chain AI, you just need to know how the internet computer works with canisters, how you deploy, and how you call, and that's it. The languages that we personally really like is it's Motoko. We are both Motoko developers as well. But if you know Rust, then definitely just use Rust. So we yeah, that's really it. If you don't know a language yet, I definitely recommend to learn Motoko. That is the language of the internet computer. There's great training material. So if you know a language, use that. If you don't know a language, use Motoko. That's always my recommendation.
Yeah, so we're using Motoko and C++. If you really like talking about running the developing large language canisters, I think at the moment that would be C++ or Rust. That's where I've seen the most progress. So for example, in Motoko, as far as I know, there's no way to run basically a Motoko large language model in a canister. We use Motoko because we think it's a great language for all the other features the IC has, and really, for example, for tying together the different large language models and coordinating them. But yeah, like go with what you know, and for the pure AI stuff, Rust and C++ looks good. For all the tooling around it, I think you really have to, you can really pick whatever tool you feel most comfortable with. And just a note, like for at least our implementation that we're working on currently, you won't need to be a developer and be able to spin up your own large language model, canisters, and so on by yourself. We will make it very easy to do that as part of the protocol, meaning it goes back to what we mentioned earlier. You will click a button and everything is being spun up for you, and you're just you can just manage the AI agents that you have as part of the protocol via a simple user interface. Again, it goes back to accessibility and making sure that hopefully everybody can participate.
Thank you. That answers all my questions. I'm going to hand it over back to Zen.
Great. We're right at the 1 hour mark. So I think we touch a little bit on ICPP Pro Bootcamp, and then let's go into big picture discussions and the future of AI. And somewhere in there, we're going to open it up to audience questions and just have a general discussion about all of this. I can't wait to get some guys up from the audience. But let's touch briefly on ICPP Pro Bootcamp. Tell us about what that is, and then we're gonna move on.
Yeah, that sounds good. I'll keep that short. Bottom line is that C++ is a very well supported language now on the internet computer, and we want to have an on-ramp for C++ developers to easily learn it, become familiar with how to write C++ for the internet computer. And the ICP Pro Bootcamp took a lot of inspiration from the Motoko Bootcamp, and we're putting it together. We had a little fundraising NFT campaign last year called ICP Art, and everybody who bought one of those, we took all the funds, split it in half between the artist, and the other half we hired a technical writer to create the first few chapters of the bootcamp, and we just released those chapters. They're out on YouTube, and yeah, we're gonna work hard to finish that. And that's it. It's really an onboarding ramp for C++ developers that are not yet on the internet computer.
That's amazing. I love that, just that natural fundraising and just splitting it down the middle and putting stuff out there. That's great. So moving on into big picture questions and the future of AI on ICP. I just might have one or two questions. Drowny might have one or two, and then I think we just open it up. We'll get some audience members up on stage to keep the conversation going. But just really quick as a place to start, really big picture. And perhaps if you can try to answer this almost like an elevator pitch style answer, I mean that would be cool. But it's big picture is why. Why do we need AI on the blockchain?
For us, it really goes back to control and coordination. So decentralized technology, we think, can provide the control mechanisms for individual AI agents that we believe users will want. And it can provide coordination mechanisms within these networks of AI agents that we will see in the not very distant future. And in both of these cases, the strengths of the Web3 space can really play out.
And just to piggyback on that, I mean, how important is the security conversation in all of this? I just read a tweet from, it was either Greg Eisenberg or it was actually like the YC account on Twitter, but their whole like Y Combinator 2025 or whatever they're doing, it's everything. The whole entire focus is AI and AI agents and agent app stores and all of this stuff. And they're talking a lot about, I believe the term is shared memory, right? And uh, based on my limited understanding of this whole picture, to me, cybersecurity seems like the largest conversation to be having, the most important thing to solve for. And so, ICP specifically seems like an ideal place to do this. Any thoughts on that?
Yeah, um, absolutely. I think if you run your AI on chain, you have solved your cybersecurity problem. That's it. If you don't run it on chain, you have work to do, yeah, and you make things more vulnerable. So at the highest level, that's it.
No, that's the perfect answer. So I would imagine we're just going to see more and more of this. I mean, as like I'm looking at this from the enterprise perspective. If you're going to have agentic systems governing critical aspects of society and infrastructure and war and weapons and transportation and all of these things, I mean, security can't even be a question. It has to be verifiably secure,
Yeah,
right?
yeah, yeah. But yeah, and another high level example is Patrick and I were just talking the other day about, hey, once we have an AI agent running on chain, wouldn't it be cool if we can have it do things from somebody from their X account? And you start talking it through, and you say, well, you know what? You're really opening it up to a problem, because X is running in an environment that's not, you have to start working with the typical Web 2 security, API keys, hackable. I would never, ever want my agent running on chain, doing things and giving instructions from a Web 2 environment. It's just not secure. But if you have uh, things running on chain, it is secure. So if you can do everything on the internet computer, controllable, security comes with it. And as soon as you have an off-chain component, you have to be very, very careful.
And just one more final quick question from me, and then I'll pass it to Drowny. Then we'll open it up to the audience. But could you touch a little bit on SLMs? I think the focus has been on LLMs, but there's the Microsoft CEO has been talking about SLMs and specialized language models, small language models, and I think ICP is perfect for this, right? Especially as these things are leveraged within the context of agents. So yeah,
Mhm.
could you touch just a little bit on SLMs? I lost my train of thought there just a
Yeah,
tad.
yeah.
Yeah, yeah.
No, I'm really glad you bring it up, because that is one of the things that we're banking on as well. The no, the SLMs, these are really just either small language models or specialized language models, and I think that's what you need to do. It's almost a necessity for us today because you just cannot run 100 billion parameter LLM on the internet computer in a canister, but you can run the smaller ones. But even if you can, what if in a few years you can run a 100 billion parameter model in a canister? It's still not the best way to do because it's a waste of energy. It's a waste of a lot of resources to have a big LLM model do something that a small LLM model can do. So we definitely see a trend of more and more specialized SLMs doing very specific tasks, and we're already going to do that in our first implementation of the proof of AI work application. We're going to have different agents using different LLMs for doing different things. You pick the LLM that's best for its task.
And Charles AI NFT is also an example of this. This is literally a model we trained for this specific use case. Don't try to talk with it about history or something. It's really dedicated to that use case. That's all we needed from the LLM, and that's all we want to pay for, and that's what we specialized it for. And yeah, like in Web3, we have to be innovative because we can't outcompete Web2 in Web2 things. So without having some of the guarantees and qualities of Web3 that we want, like for example, going through a consensus on updates. All of these are trade-offs in terms of scalability. Web2 can thus run huge models much more easily. And yeah, there is this trend towards bigger and bigger models, but we also see this trend towards smaller and smaller models. And this is not just in Web3, this is in the general AI space. So there we will see more and more projects and innovations there as well. DeepSeek looks like a very promising one. We've been looking into bit-based LLMs so that have the promise to be even more efficient. And all of these innovations really drive us towards, okay, you can run a very decent model in a very efficient way. Now, still, that model should not be the expert on everything, but if you then specialize it for the specific context you want to run it in, it can well be that it's much better than actually running a big model in terms of quality of the responses, because it's a real expert. It's been specialized for that use case, but also in terms of efficiency and actually also in terms of security. Because if you think about it, a model that's specialized on one use case cannot do as much harm as a model that can basically do anything. So if a specialized model runs rogue, it's very much limited to that one use case. If a general model goes rogue, then it can do a bunch of different things. We don't know where the limits will be. So yeah, this goes back to part of our vision around the intelligence sitting in a decentralized network and really in all the different nodes. And in that model, there is not um, one AI that's supposed to do everything, but you have a bunch of specialized ones contributed by different players who are really interested in their specific context and use case they have in mind. And then others can leverage these experts when they are fit, instead of always basically activating this one gigantic model for any little specialized task that you would need. So we think there are some real advantages to it, but yeah, we are early in the whole generative AI space, and with the small LMs, we are even earlier. But it will be very exciting to contribute to that.
Yeah, I want to touch on one point that Patrick mentioned, and that's the safety. Because we talk about security, and with security, you typically think about it's hackable, whatever. But with safety, as another aspect, you don't want the LLM to do harm, and harm can mean a lot of things. And the Charles AI NFT is actually a really good example because that LLM was trained on tiny stories, and the vocabulary is that of a 4-year-old. So it's 100% safe to have a 4-year-old play with it. 100%. It cannot, it will not hallucinate and generate stories that will be inappropriate for a 4-year-old. And that's not a level of safety that that small LLMs that are specialized, that are really trained from scratch for a certain task, can be really, really beneficial.
Drowny, do you have any big picture questions? Otherwise, we can go ahead and open it up.
Yeah. So right now, I'm paying attention to the AI trends. I am I am not an AI engineer. I can only view these trends as buzzwords at these points, but I'm very curious about your thoughts on these trends. Um, DeepSeek introduced the value of reinforcement learning, and Ilya has talked about synthetic data. Chain of thought reasoning is something that Dominic has brought up. These buzzwords, are you guys looking at these trends, and what are your thoughts on how to incorporate all these more efficient methodologies and incorporate it into the ICP ecosystem? Because I'm trying to connect the dots and see if it's feasible. It makes a feasible roadway for like more efficient small language models and also maybe even large language models in the future. Do you have any thoughts on chain of thought reasoning, synthetic data, or the reinforcement learning trends going on?
Mm, a first reaction would definitely be that these new approaches and innovations we've seen um, definitely seem to have an impact already on what it takes to train a new model. Definitely also how to fine tune a new model. So for us as well, it made it way easier to create the Charles AI NFT large language models. And I'm very sure, like without knowing it, that DeepSeek, in that sense, was also standing on the shoulders of giants and using existing data sets, maybe using synthetic data to train their model. There are these approaches to distilled training where you take a teacher large language model and you basically during training of the model you're training, a smaller one, you use the outputs from the bigger teacher model to then train the student model that you're looking at. And by doing that, you can actually distill the let's call it knowledge from the bigger models into the smaller models. And these kind of innovations really cater to the trend of first off smaller and powerful AI models, and at the same time opening up access for a much broader audience to contribute to the AI space in terms of innovation, because now you can use existing open source models like Llama 3 to train your own model and help specialize it, for example, for your context. So many of these innovations, they definitely help this trend towards smaller specialized large language models and opening it up to different individuals and teams, and also not just huge AI focused companies to do this kind of work and benefit from the technology. So I think it fits in well with um, yeah, what we've been talking about and how also ICP can play a role.
Yeah, yeah, and another trend that I'm really following closely is a lot of a lot of people in the developer community, they really just want to run their LLMs locally, which also again requires very efficient inference networks, very efficient ways to prompt your LLMs, very efficient ways to to integrate it in applications. And that I think it's worth following those, because um, you just learn a lot. You pick up techniques, right? For example, there are already people that have been working with DeepSeek, and they use DeepSeek for the first part of the answer generation, which is reasoning. With DeepSeek, it's like a reasoning model. It first starts thinking, but you can actually grab that first part of that answer and put it into a smaller, less capable LLM, and you can get that LLM to become a lot better. So a lot of these, let's call it more application-oriented techniques and research or posts, I really follow that very closely, and I'll learn from that and then start applying it in the environment we are working on.
Great. Let's go ahead and just open it up to the audience now, and love to get Bobby up on stage, Spider, Trevor, a couple of hubs in the space. I see some engineers in the space. Who has questions? Please request. Let's get you up here, and let's keep the conversation going. If not, I mean, I definitely have a bunch of notes taken, so we you know we're good on questions. But yeah, if anybody has a question, please come up. I see Swissy in the audience. Gonna send him an invite. We have the U.S. hub coming up. Let's start with ICP Hub US, and then we'll go to Joseph, and then we'll go to Cupcake.
Hello, everyone. Greetings from the U.S. Pleasure getting to know some of you in ICP community. And I just had a question for some of you. I know this probably question gets asked frequently, but things are advancing so fast. Where do you even see this in a year from now, right? Once these models are even perfected even more. Some of the issues you mentioned about running a specific kind of server for these models. And I'm also expecting a lot more announcements from different companies, right, this year. So where do you see this once it's matured a little bit more? What kind of fascinates you in knowing that it will come within a year?
Yeah, maybe I can start. I think within a year, we're probably going to see AI integrated in more and more applications. There are several projects already working on integrating AI, and it's going to be a variety of AI usage. There will be some that go with fully on-chain canisters. There will be applications that go through canisters that then do outcalls to LLMs. We hope there will be a trend towards doing it fully on-chain, and I hope that if I look at the progress made past year, if we make the same progress in capabilities of the IC and the protocol, the software, the LLMs, that it's possible to do quite a lot with a fully on-chain LLM, so that when you have an agent attached to an application, that actually everything is on-chain.
Yeah, I think we're still in the phase where many are figuring out what to do with these new capabilities we basically now gained with generative AI. Many use cases are already quite common, but I think we're still more or less on the surface. I think the broader market in terms of different projects and companies, they are really just starting to look at it and see where can we use it, how can we integrate it in our processes. And I think it will be the same on ICP as well. Many different projects integrating AI capabilities, and that will really lead to an explosion of variety in terms of what we see is possible with AI and how it's being used. So that will be super interesting to see. And I see specific as well. I think we are just starting to see this agent wave coming. And as mentioned earlier, we think there is very much going for for ICP with all its chain fusion capabilities, and so these chain fusion AI agents with, as Ian mentioned, different kind of implementations and using different capabilities of ICP. I'm personally quite bullish that that will lead to very interesting, but sometimes exciting and entertaining use cases, and really open up the space to a lot of innovation.
Let's go to Joseph next, and then we're going to head to Cupcake, then Swissy, then Trevor.
Thank you, Zen. There's been a lot of talk regarding the application layer.
No, it's hey, Cupcake, it's
Hello?
Joseph. That's next. Sorry.
Yeah, thank you. Yeah, well, a pleasure to talk to you guys. I'm in the middle of things, so I hope you will hear me well. My main question is how to integrate Web2 and the ICP in a secure way, whether it's using vet keys or CK proofs or whatever. I've been experimenting with different sizes of models. I find the best ones around 30 and bigger, so that's 30 billion parameters. That requires around 64 gigabytes of more. And on the IC, we can have like toy or specialized ones around 1.5 billion parameters, simply because of the size of the canister. You cannot do more. You can do tricks, but you cannot do more. So where I see the advantage of the ICs in the security connection and actually orchestrating securely a bunch of LLMs. So if you guys could speak about anything that you are exploring on how to integrate with Web2 securely, decentralized open source on the IC, but typical servers with big GPUs running 70 billion and more connected securely. So that's something I'm exploring. That's what I'm excited about. And if you've done any research, please let us know.
Yeah, so that's I would say is not our core expertise, but we've seen some very interesting approaches within the ICP ecosystem. For example, the Ender framework from ICPender is using a trusted execution environment, I think on AWS, but the TE can be is very portable as far as I know, so that can also run on different services, and I think there are also specialized ones. Vetkeys, I think, will unlock a new wave of what is possible. One approach, as mentioned earlier, that we have used is running large language models on your personal device. And then we want to leverage Vetkeys to store all of the user data securely on chain. So that's also an approach to take. We've seen approaches with using the ICP HTTP outcalls feature, which in general is powerful to integrate with Web2
That is
infrastructure.
what IC Caffeine is doing, by the way. IC Caffeine is doing HTTPS calls.
Yeah, I think a couple of the prominent projects are using that, and there as well it goes back to trade-off, right? If you cannot do something on-chain currently, you have to find options, and luckily ICP gives these options, and these HTTP outcalls are quite an attractive one then if that fits the use case. Besides that, I don't think I have much insight to share here.
No.
No, thank you. It's a start.
The only thought I would like to add to that is like all those techniques that were mentioned, where you're kind of going out to an LLM to have maybe some brain, a very powerful brain running off chain. I think that can be done securely with the techniques mentioned. What I would be very careful of is the other way around, where you're actually having an off-chain agent making decisions and then calling into a canister to do something. I think that's very risky. I think you have to avoid that aspect. So use an LLM off-chain just as the brain, but to actually do something, you have to be more secure and just be fully on-chain.
I think that's the key right there. I think that's the paradigm that we should follow.
Yeah.
And also one more thing I wanted to say is like, remember that if you have a desktop or a server connecting to the IC and doing, even just doing the login is fairly secure because you are connected securely.
Mm-hmm.
So that could be also a way you can run locally an LLM
Yeah.
and make it connect to the IC fully through a human, right? A
Yeah.
human authenticated LLM.
Exactly, and that's kind of what Da Vinci is already doing, because when you have conversations with the LLM that's running locally, if you're logged in, you have the option to save your conversations on the IC. So you're already doing some of that, where you have a secure connection, authenticated connection, and then it's totally fine to then update the data canister on the IC. Yeah.
Thank you, guys.
Cupcake, go ahead next.
Can you share your knowledge on the work that's happening on the infrastructure layer? For example, subnets that use Cerberus technology, and are all compute cycles equal for all subnets? So, for example, if there's a subnet where there's just the latest generation of technology, a compute cycle would cost more on that subnet than a legacy subnet.
Yeah, so happy to share the insights we have, which are really everything is through the AI working group calls, where the Definity team regularly joins and shares some updates. So the subnet idea for with the GPU is still on the table. It's technology-wise not easy at all to implement, but I think it's definitely still an option that Definity is pursuing. In the meanwhile, they're looking also at the new specification for node providers, so that would then become the next level hardware, and which would already provide us with much improved computation hardware and thus infrastructure. Um, all of the cycles between subnets are actually the same, and I'm not sure if that would be something to change if a subnet has GPUs or not. That might be actually an open question. In the short term, the Definity team is also looking into some quicker wins just to enable teams building on ICP to incorporate AI features. One idea there is having a set of large language models being hosted in some kind of, let's call it, system functionality, and then developers can use the system functionality to call these LLMs, and they would still be integrated with the network, but would not run as traditional subnets. But that would be an easier approach for now, and would already provide us with much enhanced capabilities. In terms of other improvements, so a regular topic we have is around the instruction limit. And there have been ideas, for example, within the group around making query calls much more powerful. So there are query calls and update calls on ICP, right? Update calls have a much higher instruction limit, and that's why we are using them currently, but they go through consensus, so are also more expensive. Query calls don't have to go through consensus, but for that reason also have a much lower instruction limit. And as part of the group, we've also been discussing, could there be innovations around these query calls such that AI functionality can be used within a query call or even a chain of query calls. And we've discussed ideas like, for example, charging for query calls, which is currently not the case, or at least being able to opt in for query calls, and that could potentially then really lift the instruction limit for that. So Jessley from the Side AI and Icarus, two regular joiners, have, for example, proposed that idea. And so there are these ideas floating around. In terms of next concrete improvements, we'll see that will be WASM 64, even though for us the instruction limit is the bigger bottleneck. And in yesterday's call, we discussed some of the ideas I just mentioned, and so it will be interesting to see how fast we can get some of these capabilities.
Thank you very much for those details.
Sure thing.
Let's go to Swissy next. Oh, he just hopped off. Okay, Trevor, go ahead.
Can you hear me?
Yep.
Yes, sir.
Awesome. Hey guys, I'm glad you guys covered a little bit about the security, right, and the importance of building, some of these small language models on chain as well as the LLMs, right? But considering security issues, right? You talked about building out a framework within ICP for these models. Now, is there any specific measures that your team is currently taking to prevent like malicious use of decentralized AI? I kind of I mean, I have a military background, and I instantly think of like, okay, how can these models be like weaponized maliciously for certain tasks, especially for small language models where you can specifically train them to do, certain malicious acts and at a relative cheap cost. So I was just wondering, within the framework that you guys are building out, is there any specific like parameters that you guys are looking into to kind of prevent this, or is that even possible within that framework?
Yeah. At least a few, I think that that we can mention, because not at the scale of, for example, military or other like bigger security or safety threats, but even thinking about it in like a smaller scale, when it comes to running the models as part of a protocol and coordinating that, you have to ensure that it's fair, right, and that none of the AI agents are getting tampered with in an unfair manner. And so we've been thinking about how can we make sure that they are not being tampered with. And it's interesting here as well, some of the ICP features around being able to check what kind of WASM is being run, what kind of code the canisters are running. Open source in general is also a good approach to that, we think, and then being able to check the hashes of the code. The ICP model as well has some interesting features in terms of permissions and basically providing control, because you can very fine granularly manage that, and in a pretty easy manner, and very like also plainly within the functions where you implement it. So that also we think can definitely help to see, okay, who can do what, and basically based on the permissions that the controller of the canister provides. So these are some of the things we've been looking at. But yes, I think this is a super important point you bring up, and actually also part of the bigger picture we see around this proof of AI work. Providing this control and coordination, and making sure that models don't go rogue, but actually stick to their permissions and the challenges they are supposed to respond to. So even on like an individual level, if you have an agent that's supposed to manage your DeFi portfolio, right? Just check every day how my tokens are doing, and potentially give it some specific permissions for something like a stop loss, and then make sure to sell that. You would want to know that it's actually doing that work. And we think the protocol we propose, and are also currently implementing completely on ICP, is you have a challenger. In this scenario that I just said, the challenger would be you, but you could also have an additional AI model that's kind of specialized to be this challenger or like task provider, and say, okay, your task is exactly this. Each day manage my portfolio, and this challenge is then given to the agent. The agent then is supposed to decide on which actions to take, assemble the information, and can then provide that as part of this little protocol you've set up. Next step would then be there is an evaluator or judge that you have set up. Again, this can be a very specialized AI agent, and this agent's task is simply to check the response and make sure these actions are in line what were originally agreed upon. The other model is not going rogue. It's not overstretching its permissions. It's doing exactly what it's supposed to do. And only once that other AI model has basically certified that that's the case, the response actually is being put into the system. And maybe you will have some additional checks on it, maybe some sanity checks, like you can be flexible there, right? But only once it really went through this protocol, actions would then literally be put into place, and for example, a token would be sold. So there are some mechanisms that can be implemented with this framework around control and basically different agents being coordinated and thus also controlling each other, or at least helping to do it. Beyond this, we haven't looked into the concept, but these are some of the things we have considered.
So similar to like I guess like an honest swarm method.
Yeah, exactly. So that could well be one of the implementations of the proof of AI work, where you really coordinate the swarm and with the goal to have all players basically in check and balance and honest, and at the same time the system overall contributing to a positive outcome.
Awesome. Thank you guys so much. You guys answered every question perfectly.
Thank you.
Let's go to Swissy next.
Yeah, definitely. Like the excellent space again, Zen and Drani, and definitely Onicai team for coming out and taking the time. Man, yeah, a lot of good questions answered and asked. I think maybe in terms of looking forward, like next few years, because you guys are kind of the AI experts in the space. What is the role of ICP kind of in this post web agentic narrative? And then on the other hand, kind of more immediate, what is the next thing that Onicai is working on or excited about?
Yeah, thanks a lot for the question. So if we look at this post web with all the AI agents being out there with different kind of tasks, different kind of capabilities, but often also as part of that process needing to interact with others, we think again there need to be ways to control and coordinate them, and that kind of logic needs to live somewhere, right? And a platform like ICP being decentralized and open, very accessible, we think is a great candidate to provide these kind of functionalities. So I don't think it will be exclusive. Obviously, there will be different kind of approaches, but ICP really has capabilities here that we think can be very important to contribute. And these, on the one hand, are literally, okay, you can really do powerful stuff on chain, first of all. And second of all, for stuff that you might not be able to do on chain, you can use the chain fusion features that ICP provides to expand what you can basically do. And maybe, yes, there is a trade-off then, but it often will still be better than the alternatives, right? So in general, we see decentralized AI not as most likely not as the full solution, but as like an important alternative in the market. And there will be use cases where centralized AI is maybe totally fine or better, but there might, or we think are many use cases where decentralized AI is important and great, and really has the edge. And so it is the same here with ICP. So we can, by building on a platform like ICP, really contribute important and powerful features in the overall system, and the overall system here being this autonomous network of agents. And so if we as a community manage to do that, like, I think that would be a fantastic contribution, and obviously also super exciting.
Yeah, maybe also want to add my thoughts. I think in the short term, we're still going to see a lot of kind of like developers working with it, and you have to be kind of familiar with the ICP. I also see that the ICP will kind of disappear a little bit in the background. So at some point, there's going to be tons and tons and tons of users of this that don't even know that there's ICP in the background. I mean, ICP is just a layer that enables everything. But when we develop our applications, we definitely want it make accessible for everybody. You don't have to know anything about ICP to use this capability.
So we have time for perhaps 2 more questions. If anybody in the audience wants to pop up here, feel free. If anybody on the stage has another question, please go ahead. Okay, well, I have one kind of fun question for you guys. I want to ask you what you're, just not even blockchain AI, but just AI in general, what you're most optimistic about, but then what I sort of in the world, right? Like what this technology is going to do to positively impact the world. But then on the flip side, I want to ask you about what are some of the things that you find concerning, or when you're thinking about this technology, is there anything that you kind of look out a few years into the future and it keeps you up at night a little bit?
Yeah, in terms of like general promise of AI, I think as a species, we really have the opportunity here to jump to a next level. I still think our processes in economics and also in politics, or in general in government, in agencies, but also what we do in every day, there are so many inefficiencies, and some of them might be fun, and maybe that's what keeps us going. But I think many of them are literally simply because we don't have yet had better tools. And so if we get the right tools now in place and use AI as really as the helper, then I could see like literally us doing a 10x improvement in general efficiency. And if you think about it, then how much resources that sets free for people to work on whatever they want. Um, this can unlock so much innovation, so much creativity, and hopefully that again could become like a reinforcing cycle, right? Unlocking more and more time to focus on innovation, on creative stuff, and that again can then fuel the cycle again. So that's definitely something I find in general very fascinating and promising about this new technology. I have a decent sleep, luckily, so there's nothing that keeps me up at night. I still think if I look at it broadly from a system point of view, we want to make sure for everything important we build a good system. A good system is one that cannot be easily exploited by one player, and that can then basically really affect the overall system functionality. And if I look at that, then that would mean that we should make sure that there's not like one player in this overall AI system who can influence it too much and misuse the power too much. If there are powerful players within the space, that is fine as long as there's some check and balance, but that system should not become too biased and screw over to one end or the other. And if we manage to do that, like, I'm very optimistic, but obviously, like, systems don't design themselves. There are a lot of different actors and players involved to design that, including us. Whatever role we play, we contribute. And so if we manage to do that, I'm super optimistic about everything that we can achieve with AI and also all the other technologies that will merge with it.
Yeah. Yeah, I have the same similar view. I'm really optimistic. I'm an optimistic person, and I think it's mainly positive. One thing that it's more an annoyance. I feel that there is a trend right now to just use AI just for the reason of AI, and sometimes it's put into systems where it's just not ready. It's not, and it's just annoying. So I wish people would just use AI when it makes sense, and if it doesn't make sense, then don't use it yet. So that's you asked for something that is it's not keeping me up at night, but it sometimes puts me in a defensive position when I'm interacting with people that are not into the AI world, and they're just consumers of tools and things, and then there's another tool that integrates AI in their user interface, and it's just annoying, and that just it gives AI a bad name. So I wish sometimes people would be more careful, or projects would be more careful in not using AI for the AI sake, but it has to benefit the project.
Okay, we'll wrap it up with Trevor and then Drowny.
So I'm going to ask the fun question, and if you don't want to, you don't have to answer it. But I believe the majority of the community members are foaming out the mouth, wanting to support the Onicai team. So I'm going to ask Wint Token or SNS, and what are your thoughts as far as growing the ecosystem?
Yeah, thanks a lot. There are no concrete plans currently for an SNS or a general token generation event. We are thinking to integrate a token into the gamified mining protocol that we're building, which is really the first implementation of proof of AI work. But that would be, we want to make that as fair as possible. So it would not be I guess, anything pre-minted also, and so on. And so that could be then a great way to help out. Otherwise, to support us, if you have feedback to our work, the products, the code that we have put out, if you want to contribute, because all of it is open source, like, very happy to have contributions, and see how we can collaborate there. So yeah, like, we are planning to be around for a while, so we hope there will be quite a few ways to collaborate and work together.
Awesome. Thank you so much.
Yeah. And I think we're taking it. We have the take a slow approach. Yes, we've put out some interesting things. We believe it's innovative, got a lot of interest, but there's a lot of work to be done, and yes, we need to be funded by that. So we have mechanisms to keep us going, but at the same time, to release a token today just to get a bunch of funds, I don't think it's the right thing to do. But as Patrick said, we're in it for the long run, and I'm pretty sure at some point that time will be there.
Well, I feel like the best way to support them is to actually if you are an engineer, it would be really cool to contribute to the technology, because Patrick does a really great job with the decentralized AI working group, and innovating, supporting through technology would be really beneficial. I have a question. Actually, not really a question, more of a statement. What you guys are building with the proof of AI work is very similar to what BitTensor has built. Although BitTensor doesn't put their AI on the blockchain, whereas you guys are. Um, I guess my statement is that it's just very interesting that there's a parallel right there, and I think there is definitely a demand for it, because BitTensor is a very successful blockchain network, and to put build something like that similar but on the ICP would be a huge deal in my opinion. Have y'all taken a look at BitTensor and have had any inspiration on their network architecture, or is it still kind of early for y'all in that regard?
Yeah, thank you for your words, and also bringing up BitTensor. I personally haven't looked at it much yet, but I will definitely do it after this call. So that's interesting feedback for us. And yeah, so again, like what we put out is a concept, nothing in that sense that we own. And we're sure that also others have thought about something similar. And if there are ways to together like improve it, that sounds great. And yeah, I will also take a look at BitTensor and see how that might stimulate new ideas, how we can improve the concept maybe, or also incorporate into the implementations that we are planning.
Yeah, one unique thing, I'll keep this short. One unique thing is that they have a TAO token,
Mhm.
but they have a subnet architecture similar to the IC, and every subnet has their own token that's not TAO. So
Mhm.
it's kind of like you guys, like you don't have a singular token for rewards. You guys are establishing a framework that can support any type of tokens. At BitTensor, they just upgraded to where they're supporting, or every subnet has their own token, which is kind of a like a like a credit score tracker to make sure that all miners are like this subnet is actually producing quality data. But I'll keep that. That's all I wanted to say about BitTensor.
Cool. Yeah, that sounds interesting for sure. Yeah, thank you. Mhm.
Really quick before we wrap up, I do want to give Spider just an opportunity to maybe get a question in, and then we'll tie a bow on this space. Go ahead, Spider.
Yeah, I just wanted to pop in and ask, when you guys are working in the AI working group with the reps from Definity and everybody else in the community and stuff, which parts of the network are you finding to be like um, the single or like the combination of bottlenecks that are preventing you from being able to get the larger LLMs in? I know it's probably got to be like the instruction limit and some factor of the throughput, but I'm kind of generally curious where the protocol or where the network needs to grow for at least larger, medium sized, or some of the actual large sized models to come on chain.
Yeah, definitely the instruction limit, as you pointed out. Um, in general, it would be great if at least parts of the inference of the AI models could well be run within queries, or at least like this a certain chain of queries, um, because often you don't need consensus on the inference requests. Like sometimes you want to have it, and then you can always upgrade to an update call, right? The developer is in charge. Often, like having query calls for inference is totally fine, and then only if there are updates to the canister, I don't know, permissions or certain settings, then you definitely want uh, to go through a consensus, which yeah isn't possible with query calls anyway. So, but for these kind of things, update calls are great. In terms of always having to run inference through update calls, that definitely is a limiting factor for at least for many use cases. And so that's something that we are discussing as part of the group, how we could go about it. So yeah, we are optimistic that there will be some cool innovations coming out of that, and not just for AI, by the way, but also for other high computation requirements and use cases.
Yeah, and then upgrades to the next generation hardware in general will really benefit everything.
And I'm curious what changes are they talking about making to the node spec? Because I mean, I was thinking theoretically in the background, and I'm like, there's still some unleashed potential in the hardware that operate these nodes and stuff. Quite a bit of it actually, and it's really probably just a factor of, you know, getting the message limit and the query and update throughputs for coming to consensus on the network to scale up with the capabilities of the hardware that exists already. But then, you know, you could add GPU to it. They could maybe find a way to add some ASIC circuits to it, or ASIC hardware to it, kind of like what you see with Cerberus inference, and or possibly even eventually get into using a combination of PMEM and NVMe or something like that that just helps overall performance.
Yeah. So I think what would be really interesting for you is maybe join. I think next week we actually have a session on hardware that's going to be led by one of the node providers in the DEI working group. Is that next week, Patrick?
It's in 2 weeks. So next week in the DAI group, we have the IC Panda team talk about the Ender framework. And then in 2 weeks, as Arjan just mentioned, we'll have the our monthly call on infrastructure and hardware on ICP to support AI computations. And so, yeah, that's
awesome. And then just to add to that, I do think that we'll probably also see some of that potential unleashed as well, if they can get like better parallelization with the query calls and and then also with like the decentralization of the boundary nodes. So like the entry points into the network have you know, a better potential now, so that we don't get clogged with incoming requests and stuff.
Yeah, like personally not being like a hardware or protocol expert, but still like having participated in many of the discussions, there are definitely very promising ideas floating around. I wish I could elaborate more on these, but yeah, my expertise doesn't allow. But let me see. We, as the DAI working group, we keep a repository where we have summaries of basically all of the calls, and that could also be interesting because we've had calls on infrastructure, hardware improvements, GPU subnets before. Why don't I just put it here as a comment to the space, and maybe people can check it out then.
Yeah, absolutely. I appreciate the input you gave. I don't want to hold anything up any further there. I'll probably jump in on that next working group then if they're going to focus on hardware. I just don't spend much time on Discord, and I think that takes place in the IC Devs Discord channel, right?
That's right. Yeah, in the new Discord that ICP that Dfinity established for ICP. That's right. Yeah, it would be great to have you.
Yeah, I'll absolutely try to jump in on the next one. I get, like I said, I don't spend much time on Discord, so I get disconnected from all those groups and processes and things. But it would be nice to queue in. I appreciate it.
The great thing about Discord is that they can actually share your screens, and that's the only thing that's missing from Spaces is you can't share your screen.
Yeah, I do like that feature. I appreciate all the info there. Absolutely.
Great, guys. I think we're gonna wrap the space there, but I do want to give Patrick and ICPP Pro a chance. If there's any alpha you'd like to share or any news you want to break live, please go ahead. The audience would love that. No pressure, though, of course.
Yeah, like I think we actually today on the first time we talked about it publicly that we are working on this first implementation of proof of AI work, which will be the basically a mining protocol fully on ICP, and we don't have a release date yet, but we'll definitely keep all of you updated. And yeah, then looking forward to feedback and engagement.
No. And the plan is to use different LLMs, on-chain LLMs in there. And we're definitely going to try hard to have the DeepSeek LLM be part of it.
Great. And where can people find you? Where can people support you? How can people get involved?
Yeah, so our social media is really here on X and on OpenChat. We use OpenChat literally every day. That's where we coordinate with the team. So Arjan, Nuno, and Abhishek, who's our technical writer for the C++ bootcamp. It's all on OpenChat, and we have a Onicai community there. And otherwise, you can also reach us on the forum. We have a couple of threads there for the on-chain AI, but also the on-device one with DaVinci. And otherwise, also happy to see everyone in some of the DAI working group calls or reach out to us directly with here on X, or there's also some contact information on our homepage, which is just onicai.com.
Great. Well, I hope everybody in the space, please go give both of these guys a follow. Follow Onicai, connect with them on OpenChat. I hope the engineers and the technical people will join the working groups and get involved on GitHub. Yeah, I mean, with that, guys, I think we're going to land the plane here. I want to give a huge shout out to Drowny for coordinating this space, and obviously extend a massive thank you to both ICPP Pro and Patrick. This has been an absolutely wonderful event. Such a pleasure to hear from the guys working on the cutting edge. And I want to give a huge shout out, of course, to the audience and this ICP community, this wonderful community on X. You know, you're really the backbone of this community. People showing up every day to lend support and support these builders and the guys on the front line. So thank you so much for doing that. I'm going to run through I know you guys haven't been on a space before. We like to end doing some shout outs through the audience. So I'll do that. And then we're going to call it a night, guys. Thanks so much for tuning in. So with that, big shout outs to Drowny, Trevor, Spider, ICPP Pro, PF, Cupcake, Megasky, Crow, Swissy, DREF, Chris, Poru, Philip, The Banana, TI, Chief, OI, Chingao, Bambino, Wazer, El Chingon, Alwyn, Satori, Canistor, Digital Lala, Ashley, Zoe Duffy, Game On, Simon, Hero, Aped Lebitin, Romulus, Salville, Worm, J. Marco, Tundi, Kumai 888, IC Bat, Ant, Nong 1160, Banks, ICP Fan, KKI, Naj, Matuez, Yishai, Abdi, Olak, Dimitri, Samuel, Big Tech Cloud, Steve Sneed, and the one anonymous listener. Guys, thank you so much for tuning in. Good night. God bless. This is ICP General. We will catch you on the next one. Much love. Goodbye.